Welcome back everybody to part 2 of our sorting data topic. Now in part 2 we're going to start looking at how bubble sort works, and to begin that we need to start looking at a very fundamental part of the bubble sort algorithm, and that is how to swap two different values or two values at different positions in the data structure with each other. Now, before we look at the correct way of doing this, we're going to look at what happens if we don't use the correct way of swapping data. Now, when you want to assign a value to a variable, what you would do is, for example, if we want to assign a value to this index of the array, so we would say, for example, mylist bracket 0, so index 0, then we would say arrow, which is the pseudocode way of saying assign to. We would say, for example, let's say 6. So what this would do is it would take the value 6 and it would store it here in this index like so. Now we don't want to store the value 6 there. What we want to do is we want to store in index 1, we want to store whatever value is in index 0 of my list. So what we're basically saying is whatever value is in my list index 0, we want to assign that to the index 1 of my list. So what this is going to do is it's going to take this value here and it's going to copy it over into index 1 like so. Now this is fine. What we've done is we have taken the value 5 and we've put it in my list index 1, which is the first part of the swapping process. But now the problem is, if I then say my list 0, so index 0 is going to be assigned to my list index 1, what's happening here is, I'm just going to copy this like this. So what's happening is we're going to take the value at my list 1 and we're going to copy it over to index 0. Now if you haven't noticed, we've actually lost data. We haven't swapped anything. We've carried the number 5 to index 1, and in doing that we've actually overwritten the data that was originally there. The whole point of swapping is that index 0 should now be value 2 and index 1 should be value 5. So doing it this way is incorrect. We need to add an extra step to this, which brings me to my next slide. So this algorithm here that you can see shows you that we're going to need a temporary variable for this swap algorithm. Now, you can name this variable whatever you want. It doesn't have to be temp. What's important for you to understand is that whatever the data type of the two values that you're trying to swap is, temp has to be the same data value. Now, of course, if you're using a programming language like Python, you don't have to worry about declaring your data and so on and so forth. But if you're using a programming language like C#, when you declare temp, it has to be the same data type as the two values that you're trying to swap. So what's going to happen here is the variable temp is going to be assigned to whatever value is in my list as 0. So we're going to take the value here and we're going to copy it over to the variable temp. Now the second line says, my list index 0, so this position in the array, is going to be assigned to whatever my list 1 or index 1 is. So we take the 2, we copy it over to index 0. Now you might be thinking, sir, we've just lost, or we've just overwritten over the data that was there, but don't be scared, because this is why we have the temporary variable. So what's going to happen now is in my list index 1, we're going to assign whatever we copied over to the temporary variable. So we're going to bring that 5 down, and we haven't lost any data. we still have the same two original values and they have swapped position. So whenever, from now on, whenever you hear the term swap algorithm, these three lines of code should automatically come to your mind. You need to set your temporary variable. You need to then assign one of the indexes to the other, or one of the values to the other variable, and then just bring over from temporary variable to the one that you copied over. Now, the other thing to understand here is that this algorithm for swapping two values doesn't have to just be for things in an array or in a struct. This algorithm could just as easily be used for swapping values into independent variables as well. So it doesn't have to be just a struct. It could be, it doesn't have to be just for an array. It could be used for swapping values on two different independent variables as well. Just keep that in mind. Now, I know for people who use something, a programming language like Python, Python does have something called concurrent assignments. And that means that what you could essentially do is you can say my list index 0, comma my list index 1 is equals to my list index 1 comma my list index 0. So what this does is it just basically does the swap algorithm for you. But in computer science, we're not learning, how to use these easy methods to do this, even though it's perfectly fine to use these in the industry. But as part of your computer science education is that you actually understand what is happening in the background and how your computer is managing to complete the task at hand. So now let's look at this algorithm in a little bit more detail. I'm just going to center my screen here. Just bear with me, please. We don't really need this information, so I'm just going to delete that. Right, so we're going to have a look at this algorithm, and we're going to see how this algorithm, this swap algorithm here, is going to swap these values in this array. So we're going to look at the bubble sort algorithm now in a little bit more detail. This blue outline here is going to highlight which line of code we are currently looking at. So we're going to trace this algorithm, and when you're tracing algorithms, it's important that you go line by line. Even if you are pretty certain that you know what the algorithm is going to do, it's important that you look at the algorithm line by line, because there could be something there that's either an error or is not working exactly the way you want it, and you might need to make it a bit more efficient. So whenever you're tracing algorithms, please trace it line by line until the end. So what we're going to do here is we're going to start our for loop, and we're going to initialize this variable I, which is going to be represented over here by this box with this square, and we're going to assign the value 0 to I on the first line. So I is going to be the value of 0. Now I'm going to bring not the whole algorithm, we're just going to bring this rectangle here. Now what this is asking us, or what it's checking, is it's saying if list I, so if we look at the variable I, we can see that its current value is 0. So what this is looking at is if list 0, index 0, so we're looking at this index right here, is greater in value than list I plus 1. So I again is currently 0. So list 0 plus 1, which calculates to 1 or results in 1. So it's looking at this index right here. So now basically we're saying, or the algorithm is checking if 5 is greater than 2. Now that is a true statement because this value here is greater than this value here. And because that is true, we're going to execute these lines of code here. Now temp, this variable here, is going to be assigned to list I, so list 0. So we're going to take the 5 and bring it over to temp. The second line of code, I'm going to be bringing this square down here. The second line of code here is saying list I, again, list 0, is going to be assigned to list 0 plus 1. So we're going to take the number 2 and we're going to store it in this index here, index 0. And then what we're going to do is we're going to take whatever value is in temp and we're going to assign it to list 0, 0 plus 1. So we're basically taking the number 5 and we're storing it in this index, overwriting whatever value was in there originally. So what we've just done is we have just swapped these two values because the value on or inside index 0 was greater than the one in index 1. So we are already bringing the smaller values to the front and the larger values to the end. So then what we have to do is we're going to end the if statement, we're going to go to the end for, and then we're going to check the condition. We haven't reached the end yet because this for loop will go all the way up to the value 3. So I is going to be incremented now, and from 0 is going to turn to 1. And then when we look at the if statement, we're checking if list 1 is greater than list 1 plus 1. Now what this is looking at is basically if this value right here in index 1 is greater than the value in index 2. Now that is a false statement because 5 is not greater than 7. So we do not execute these 3 lines of code here. We again go to the end if, we go to the end for, we go to the top again, and the I variable gets incremented one more time and it turns to 2. Now we go to the second line of this algorithm, like so. And now instead of checking for index 1, we're in fact checking for index 2, and we're checking to see if that is greater than list index 2 plus 1, so that's 3. So we're looking at this index here and this index here, like so. Now 7 is greater than 1, so that's a true statement. And then we're going to execute the swap algorithm. So temp is going to become, or is going to be assigned to whatever list index 2 is. So we're going to bring the 7 over. Then we're going to execute this line right here. So list index 2 is assigned to list index 2 plus 1, or 3. So then we basically take the 1, we bring it over to this index right here. And then lastly, with our swap algorithm, we say that whatever value is in temp, we're going to assign it to index 2 plus 1, or 3. So we take the 7 and we bring it over to this index here, like so. And what it looks like is that index 2 and index 3 were swapped with one another. And then what's going to happen is we're going to go to the end if, end for, go up to the for loop, and we have one more increment to do. So we're going to place the value 3 and I, and then we're going to check if list 3, index 3, forgive me, is greater than list 3 plus 1, or 4. So now we're looking at this index here and this index here. Now keep in mind this is now 7, so 7 is greater than 6. We're going to execute these 3 lines of code. So again, these 2 values here are going to swap. So 6 is going to be in index 3 and 7 is going to be in index 4. Now you might be asking yourselves the question, well, the first question you might be asking yourself, if you are a critical thinker, like I wish you are, why is the algorithm only going up to 3 when we have the last index in the array being 4? The reason for that is if the for loop goes to the last index here, then what will end up happening on this line on the if statement is it will check list index 4 with an index which doesn't exist when it says I plus 1 here. So there is no need for you to check the last index in the array with the next index which actually doesn't exist. So this is the reason why the for loop should only go to the index before the last one in the data structure that you're trying to sort out. The next thing that should be in your mind is, well, it's fantastic that we've sorted a few numbers out, but actually this still isn't sorted perfectly because 1 being the smallest value here should be at the very front. So it should be where the number 2 is in list 0. What you need to know is that one complete for loop goes through the array, goes through the data structure, pushing the heaviest item towards the end, but it doesn't sort out the entire array in its first go. What you'll need to do next is you'll need to repeat this for loop again, well, that's what repeat means, so that it sorts the numbers out again, either in a perfect ascending order or closer to an ascending order than it is now. And then if that doesn't sort it out completely, then you would run the for loop again, this exact algorithm right here, to sort out the numbers again until you have a perfectly sorted array in ascending order. Now, because you don't know how many times you need to run this for loop, what you'd have to do is you'd have to put the whole thing inside of a while loop and then check in its condition to see somehow if the array has been sorted or not. If it has been sorted, then you would end the while loop. If it hasn't been sorted, well, the while loop will just run continuously until the array has been sorted. Okay? But what's really important for us to understand here is that one complete pass will always push the heaviest item of the array towards the end. The second thing to know here is that as you were going through this array, sorting this data out, again, your natural human instinct would have told you, well, before you push the number 7 towards the end, why don't you just do this swap here, where you swap the 5 and the 1, because that's the logical thing to do. But what you should have noticed very, very carefully is that the algorithm doesn't stop and check if the index which it just swapped should be swapped again. It continues looking at the next indexes as it goes along until it pushes the heaviest item towards the end. This is very important for us to understand, because when we trace bubble sort algorithms in the future, you don't want to make the mistake of changing values like this earlier than they need to be changed, or earlier than the algorithm would have changed them. So we're going to look at tracing in the next part. So see you then, or speak to you then.